Reports are usually generated from data found in multiple tables. Join statements help combine the data from the two tables into a single result. The tables are combined by comparing columns, usually with the assignment operator, the equal sign, from the left table and right table. Joins typically compare the foreign key of one table with the primary key of another table, but can also compare any column as long as the column has the same data type. Sometimes the join tables can contain columns with the same name, and when this happens, you need to prefix the table name followed by a period and then the column name so that you can distinguish them. So in the two tables at the top, we have a JacksonFive table, which lists all the members of the JacksonFive, including Michael, Tito, Jermaine, Marlon, and Jackie. And we have ID as the primary key. And then there's also SoloArtist, which lists a bunch of artists that have made solo albums like Kanye West, Michael Jackson, Eminem, Jermaine Jackson. And that also has an ID column. So the query shown here, the select s.name, s.networth from SoloArtist S and JacksonFive J. So we're basically just giving an alias to SoloArtist S and JacksonFive as J, so that we can, because they both have the same ID column, and that way we can distinguish which ID column belongs to which table. So where we say where j.id is referring to the JacksonFive ID, and s.id is referring to the SoloArtist ID. So the query selects rows for which the primary key of JacksonFive is equal to the primary key of SoloArtist. And since we're using the same column names of these two different tables, that's why we prefix them with S for SoloArtist and J for JacksonFive. And if you look at the join results, we'll see that there's Michael Jackson and Jermaine, because they're the only two of the JacksonFive that created solo albums. And it also shows their net worth. And by the way, I totally made up these numbers for their net worth. I think Jermaine Jackson's probably worth a little bit more than $5.34. A join always shows the matching left and right table rows. However, you may only want to see unmatched rows from a left table, right table, or both tables. And there's several types of database joins that you can do. One of them is an inner join, which selects only matching left and right table rows. So if you look at the diagram in the middle, you'll see that with table A and table B, the only ones that are highlighted in blue are the rows that exist in both tables. So that's going to be the results of our join. And the next three tables, left join, right join, and full join, those are all examples of outer joins. A left join selects all left table rows and only the matching right table rows. A right join is the opposite of a left join, where it selects all right table rows and only the matching left table rows. And a full join selects all the left table rows and all the right table rows. So the results tables of an outer join may contain unknown values, and those become set to null. So when creating a join, the from clause uses the left table and the join clause uses the right table. And the on clause is used to specify the join columns from the table. So in the column on the right of this diagram, we could see the select statements that you could use for creating inner joins, left joins, right joins, and full joins. And besides from, inner, and outer joins, relational databases have a few other types of joins, including an equijoin, which compares columns of two tables with the equality operator, the equal sign. And they're the most common types of joins. Actually, all inner and outer joins are examples of equijoins. A non-equijoin compares columns without using the equality operator, such as using a less than operator, less than or equal to, greater than, or greater than or equal to. A self-join is a table that joins itself by comparing any of its columns that have comparable data types. If a foreign key and the reference primary key are in the same table, a self-join can be used to compare key columns. If you're using a self-join, you may want to use an alias, which is a temporary name for your table or column, and it makes dealing with SQL statements easier if you're comparing columns with the same name in different tables, or even within the same table in a self-join. Then finally, there's cross-join, which combines two tables without comparing any of the columns. The result is all possible combinations of rows from both tables.